Hello, welcome once again to the new session of Premade Pro, and we are continuing the chapter Molecular Basis of Inheritance, and this is the next topic we are going to start. This is the translation. Translation, as far as the central dogma, we know the translation is a mechanism by which the mRNA is converted into the protein, and the transcription is the process by which the DNA is converted into mRNA. So, give us the topic as translation. Translation. So what is translation? I have said that mRNA into protein. This process consists of the three identical steps. The first step is initiation. The second step is elongation. Initiation, it had to be started first, then it has to be elongated. Then the last step is the termination. So it must be terminated. Whichever is initiated needs to be terminated. Okay. The last step is termination. So you know what? Amino acylation of tRNA. That is also called as charging of tRNA. Okay. Amino acylation of tRNA is also called as charging of tRNA. In this process, the first is activation of amino acid. Amino acid needs to be activated first. Amino acid. So what you get? Amino acid is activated by how? Amino acid plus the action of ATP, because energy is required. Okay. So amino acid plus the ATP makes amino acyl adenosine monophosphate. So amino acid reacts with the ATP and forms amino acyl monophosphate. So amino acyl monophosphate plus polypeptide. Okay. The next one, amino acid monophosphate, is an active form. It is active form. Now the next part will be the charging of amino acid was inactive, right? Is inactive, and amino acyl monophosphate is thus active. The next part is the charging of tRNA. tRNA needs to be charged first. Okay. So amino acyl AMP plus tRNA forms charged tRNA. Forms amino acyl tRNA plus the AMP. So it is the charged tRNA. Amino acyl tRNA is the charged tRNA. Okay. Amino acyl tRNA is the charged tRNA. This reaction is catalyzed by amino acyl tRNA synthetase. So write it. This reaction is catalyzed by amino acyl tRNA synthetase. So now come to the next part, that is the initiation. Come to the next part, that is the initiation. So in initiation, this mRNA binds to smaller subunit of ribosome. mRNA binds to the smaller subunit of ribosome. So it is a dissociated state. It is a dissociated state. What is the dissociated state? Here you see the ribosome may be of 30S/40S. 30S is on prokaryotic and 40S is of eukaryotic. Okay. Now, one is the initiation codon. That can be AUG. It also codes for methionine. And the 2 is for termination codon. Neat. Okay. Now the next part. The next part is the first tRNA carries as initiator carry first amino acid. P is formyl methionine and E is methionine. Formyl methionine and E is methionine. Anticodon. A1. Now the anticodon part. So anticodon part, the first one, and this is the second one. This will be B. So prokaryotes contains 3 anticodon, that is IF1, IF2 and IF3. Okay. And eukaryotic consists of 9. Okay. Prokaryotic consists of the 3 and the eukaryotic consists of 9. Okay. Now, in the third part, binding of larger subunit of ribosome, that is 50S/60S to smaller subunit. Prokaryotic and eukaryotic. Okay. Now what happens? See here, this is of eukaryotic, this is of prokaryotic, the peptide. This is called exit. P is for peptide and A is for amino acyl. Okay. Now here association is completely formed. Bracket a ribosome. Okay. Now this is E This is the anticodon. This is the first, second, wait, this is first, this is second. Okay, this is the amino acid. GTP consumes energy, okay. Now what happens? So it is associatively formed the ribosome, and later on this part the initiation is completed. Now what comes to the next part is elongation. So in elongation, so in elongation, binding of second tRNA at a site. A1, A2, energy required. It is P. It is the peptide bond. The first one, the second one. GTP is required. Here, GTP required. That is, energy is required. Energy is required. Now what happens here? It is the amino acid site. Okay. Now what happens? Here, the peptide bond is formed. The peptide, explaining the figure, the peptide bond is formed. Peptide bond is formed between two amino acid. Okay. Now here what happens? NH2 Cr. This is the carboxyl group. It reacts with amine group C, single bond H. It can be ethyl group. Now here what happens? This is the first part, and here amine group reacts with amine group R COOH. No, it not be COOH. CO. Okay. Bonds with amine group CH R COOH. Here it is a peptide bond. It is peptide bond. Okay. So a peptide bond is created in the elongation. Now what happened? By the enzyme peptidyl transferase enzyme. It happens by 23 S RNA in prokaryotes is 50s part, and here in 28 is RNA in eukaryotes, that is in 60s part. The ribozyme RNA acts as enzyme catalyst. RNA acts as enzyme catalyst. Now what happens? See, now what happens? The tRNA at P site degraded and moves out through exit. Paste empty. P site is empty. A site occupied. First, second, and third. Movement oblique sliding of ribosome on mRNA run 1 codon oblique 3 base. Note, take it as a note, elongation factor eukaryotes EFTS, EF and G. These are the elongation factor, and for eukaryotes the elongation factor is, if the question becomes too hard then this will be asked, else it will not be asked. If the question becomes too hard then it will be asked, else it's not to be asked in the NEET. Okay. Now for the termination, elongation is completed. Now for the termination, it is to end up. In termination, the tRNA for termination, the tRNA of P site degrade and moves out through E site. Okay. Now the protein synthesis stops. Last amino acid growing polypeptide chain at P site. The growing polypeptide chain starts to grow at the P site. Okay, so the growing polypeptide chain starts to grow at the P site. Now what happens? The releasing factor comes into effect. The releasing factor, what has produced has to be released, na? So the releasing factor, the protein for the releasing factor is RF1 and RF2. They are the separate polypeptide chain form tRNA. Okay, these are the separate polypeptide chain formed by the tRNA. Now, in the next video, I will start from the mRNA. mRNA will be covered, the tRNA will be covered in a single lecture, and the mRNA and tRNA will be covered in the single lecture. Okay, so it will be a very much short video. The mRNA tRNA will be completed in more than within 15 minutes of lecture. It will be completed. So it will be a short video because question will come from that part. So I am making a short video on that mRNA and tRNA. That will be very much beneficial for you all guys before the examination. Okay, so till then have a good revision on this chapter, and if you find any question, please ask it in the comment box, and please subscribe the channel, please share it with your friends, and please like it. Okay, good night.